Hi everyone, my name is Ritika Goswami and you're watching this video on my channel which is RG Explains, where I try to explain chemistry with relevant examples because why not? In today's video, I'm going to be talking about Sn1 and Sn2 reactions real quick, so let's begin. So point of view, you're at a pizza party, okay, and I hope you guys love pizzas. So now you're expecting a great night of free pizzas and then you realize something very bad, which is that there's a bodyguard standing at the front door who's trying to avoid your entry. Well, that's bad, right? But you, being the smart pants that you are and the pizza lover that you are, you still manage to enter the party through the back gate and you enjoy these amazing pizzas all night. Well, this is exactly what happens in case of an Sn2 reaction, which is attack from the back, okay? This is what happens. This is the strategy of an Sn2 reaction where the nucleophile is going to attack from the back, okay? So let's deep dive into the chemistry part a little because we have to, okay? So in Sn2 reaction, we have a substrate molecule, which you can just see on your screen, which is methyl chloride, okay? And before I begin explaining what is an Sn2 reaction, I think I will first mention that in Sn2 reaction, it is always going to happen in one step, okay? So it's Sn2, so it happens in one step. That's why it is also called a concerted reaction, since it happens in one step. So now, in this case, the carbon is having a delta positive charge because it is attached to a chloride atom, which is of course electron attracting in nature. It is electronegative in nature, which acts like a bodyguard, okay? So now the nucleophile, who is ready to give away its electron to the carbon atom, wants to eagerly make a bond with carbon atom. But there's no way. The front gate is occupied by the chloride, okay? But there is one thing which can happen. The nucleophile, instead of attacking from the front, is going to attack from the back side. But what is there on the back side? Exactly opposite to the CCl bond, there's an anti-bonding, okay, orbital of the CCl bond where the nucleophile is going to attack, and that is exactly what happens. The backside attack is going to happen, and now here you can see there are five bonds which are formed with the carbon atom, which is of course not possible. So CCl bond will have to break and chloride will have to be the leaving group, okay? Now you'll notice that in Sn2 reaction, what actually happened is that the substrate that we had, okay, that had a certain geometry, but because of the backside attack of the nucleophile, that geometry has actually inverted, okay, because the nucleophile actually entered through the back gate, and this kind of stereochemical inversion, which is seen in this GIF right here on the screen, is exactly what happens, okay? So in this case, only one major product is formed because only one type of attack, which is the backside attack, is possible in this case, because in the front we have the bodyguard, okay, which is the chloride here. So if I compare these two substrates, the backside attack has to be here and here it has to be here. So if you look carefully, what do you think? Where is the attack more easy? Of course, here we have just small hydrogen atoms, okay? So it's not that bulky, it's not, the steric hindrance is not that much. That's why here the rate of Sn2 reaction is going to be quite fast, but here it's going to be really less. Why? Because here we have big CH3 molecules which are going to avoid the backside attack which is going to take place by the nucleophile. So if I show you in a very small span, this is exactly what happens. The backside attack happens, the leaving group leaves, and the geometry is inverted, which is called stereochemical inversion. This is exactly what is an Sn2 reaction. Now let's see what happens in case of an Sn1 reaction. So again, the imagination part remains the same. There's a door, there's a bodyguard, there's free pizzas, and the hungry you, pretty much the same, okay? But now you do something different. Now you wait for the bodyguard to exit the party, and now you make your move. Now you will try to enter the party. And since there's no bodyguard now, you have the luxury of choosing from where you'll enter. You can enter through the front gate, because that's what you can do now, and also from the back gate also, because now there's no bodyguard. There's a luxury of choosing from wherever you want to go inside the party, you'll go, because, well, why not, okay? And this is exactly what the strategy of an Sn1 reaction is, which is create a place first and then attack, okay? So as I said, there's two steps involved in this reaction, okay? Sn1 reaction takes place in two steps, which I think I just gave a hint of. Create a place first and then attack. So the first step is in which you create a space. What is that space? So as you can see, there's a substrate molecule here. And now, because of the inductive effect, okay, first there's a carbocation formed. And as you can see, the carbocation is highly stable here because the three methyl groups are going to be stabilizing the carbocation to a high extent, so it's not that unstable now, okay. And this is what is called an intermediate. The carbocation is called the intermediate, which is what did not form in case of an Sn2 attack, okay. Now this intermediate, which you can see here, okay, is basically a carbocation which is having an empty p orbital, okay. And now the nucleophile has the luxury of attacking from wherever side it has to. It can attack from the front side or it can attack from the back side, whatever it likes, but only one will happen, right? Because if both of them happens, there will be 5 bonds, which is not possible, okay. So basically both the attacks are possible and both the attacks will happen in 50-50% rate, okay. And both stereochemical isomers are going to be formed in equal quantities, and since they're going to be in equal quantities, like it's called a racemic mixture, where you have equal quantities of both the stereochemical isomers, okay. So if I compare again these two for an Sn1 attack, of course in this case the carbocation which is going to be formed is going to be this 3 hydrogen atoms and plus, okay. And here, as we know, is going to be this. So of course the carbocation, this one, okay, the trimethyl carbocation is much more stable because of the inductive effect, and this one is of course very less stable. So in Sn1 reaction, this is going to be preferred, okay. So guys, that's exactly that's it. This is what an Sn1 and Sn2 reaction is. And if you like the video, you know the drill. Do press the like button, share it with your friends, and thank you so much for watching. Stay tuned for more.